When multiplying a rational expression, the first thing we want to do is we want to look for factors that we can cancel out from both the top and the bottom. If I look at this example, one of the things that I can cancel out is a 5 and a 10. If I divide them both by 5, the 5 is going to become a 1, and the 10 is going to become a 2. Another thing I can cancel out is the c's. I've got two c's on the top and one c at the bottom, so one of them is going to cancel, and it's going to leave me with one c on top. There are no other values that can cancel in this example, so I'm going to multiply. C times d is going to give me cd. On the bottom I've got 2 times 2, and that's going to give me 4. My last step is to indicate any non-permissible values. The only non-permissible value in this example is going to be c equals 0, and it comes from this term here where I've got 2c in a denominator. The only value for c that would make this denominator equal to 0 is 0. In my other denominator, the value is 10. There is no way to make that denominator 0, so therefore our only non-permissible value is c is not equal to 0. In a slightly more complex equation, I have factors in each expression. Now here I've got a factor of 4x and then a separate factor of x plus 3. In this side I've got a factor of 5 and a separate factor of x minus 1. My denominator here is I've got a factor of 3 and a separate factor of x minus 1. And then finally my denominator in my second expression is 2x. When I'm canceling expressions here, I'm looking for factors that are identical or that can be divided by the same value. So one of my identical factors is x minus 1. So I could cancel that entire factor. Another factor that is the same is the x's here. So I could cancel those x's. And finally, I can divide both of these numbers by 2, which is going to leave me with a 2 here and a 1 here. The final step is multiplying all of our remaining factors together. So 2 times 5 is going to give me 10. There is also an x plus 3 factor remaining, and in my denominator everything is cancelled out except for the 3. Finally, I need to indicate my non-permissible values. I have two places here where I have an x in the denominator. The first place is in this x minus 1 term. Now even though it's cancelled out, I still need to indicate the non-permissible value of 1, because if I make this 1, 1 minus 1 is going to give me 0, which is going to make a denominator of 0, which I can't have. In the other one, 2x, the only way to make that 0 is to have x equal to 0. So as a result, in the expression 10x plus 3 over 3, I can't have an x that's 1, and I can't have an x that's 0. Because even though we've canceled them out, at some point in our equation, that would make our expression undefined. Finally, here's an example where I'm going to need to factor. So I'm going to start by factoring this term here. X squared plus 5x plus 4. I'm looking for a number that's going to multiply to give me 4 and add to give me 5. So those two numbers are going to be 4 and 1. So my factors are going to be x plus 4 and x plus 1. In my denominator, I'm going to factor out a 2 first. So just to show you, I'm factoring this expression now. I'm going to factor out a 2, and I'm going to be left with x squared minus 4x plus 4, which I can then factor into 2, x minus 2, and x minus 2, because that will give me positive 4 as a product and negative 4 as a sum. My factors on the top will remain the same. Now in my third one that I need to factor, so this one up here, I'm going to factor out a common term. So I could take out a 4, and I get x minus 2, and since this x minus 2 can't go any further, that's going to be in my last expression. And then finally, I've got x squared minus 1, so when I factor, it's going to become x minus 1 and x plus 1. My last step is to look at all of my factors and look for things I can cancel. I may cancel anything that's on the top with anything that's on the bottom. So I'm going to cancel my x minus 2's, I'm going to cancel my x plus 1's, and I'm going to cancel a 4 and a 2, which is going to leave that as a 1, and that as a 2. My final step is to write any remaining factors. So here I've got a 2 on the top, and I've also got an x plus 4. On the bottom, I've got an extra x minus 2, and a remaining x minus 1. Now I need to determine the values that x can't be, and I need to do this for all values of the denominator. So this one and this one are both going to give me a value of x cannot equal 2. This one is going to give me a value of x cannot equal 1, and the final one is going to give me a value of x cannot equal negative 1. So those are really the steps that you're going to need to go to simplify when we're multiplying a rational expression. You're going to factor. You're going to look for values that are the same on the top and the bottom, and you're going to cancel them. You're going to write the remaining factors in your summary of your answer, and then finally, you're going to write the non-permissible values.